Now let us try to find out what will be the amplitude of oscillation in a cross-coupled oscillator. Amplitude of oscillation in LC cross-coupled oscillator. We can redraw the circuit. And now let us just call this total inductance as L, capacitance as C, and the loss of this tank as R. We know that this cross-coupled pair is compensating the loss by providing a differential current to this tank. So we'll try to plot how this differential current looks like when the oscillator is oscillating in steady state. So let's call these voltages as VOP and VOM. So in steady state, this differential voltage VOP minus VOM may look like sinusoidal. So this is VOP minus VOM. So we are plotting these things in steady state. Now if we look at this current I differential, we can see that these swings are going to be large signal for these MOSFETs. So their GM is not going to be constant. And at the same time, we'll also see that this current will also be not sinusoidal. So here we are assuming that this swings at the output nodes are high enough that it is, when it is going up, it is going to cause the gate voltage to increase. At the same time, the drain voltage of the same MOSFET is also going to go down. So the net result is the current passing through a transistor will stop increasing after some time, even though the output voltage may be increasing. So in an approximate manner, we can say that the current is going to look like a square wave, where current will try to increase near the zero crossing of the differential output, but after that it is going to stop increasing. Here we are just approximating it with a square wave. And similarly on the other side, like this. So the current is going to first increase with the increase in differential voltage. Then in such a scenario, see that the current polarity is reversed. So this is going to be your I differential. Let's call this maximum value as I peak. So now from this current waveform, we can see that When this kind of a non-sinusoidal current flows into this tank, then this tank is going to filter out all the harmonics and only fundamental is going to appear at the output. So we can say that this output voltage VOP minus VOM is going to have an amplitude corresponding to the fundamental component of the current, which is appearing across this tank. And in this case, it is going to be 4 by pi IP into R. Okay, because this is the strength of the fundamental component in this square wave. Now here we can note that for low output amplitude, we'll see that this IP is determined by the tail current I0 max IP will be equal to I0 by 2. This is also called as current limited regime. This is your current limited regime of operation for this cross-coupled LC oscillator. IP is determined by this bias current I0. Whereas if the amplitude is high, output amplitude, the peak value of this differential current IP is determined by the supply voltage VDD. And in such a scenario, we say that the cross-coupled LC oscillator is operating in voltage limited regime. By you can see that if we choose this I0 in relation with the R in such a way that the output swing is going to be much lower compared to the VDD, then even when there is a complete steering of this current, this MOSFET, we will still be operating in the current limited regime. Whereas if we choose this I0 and R such that their product is on the higher side, in that case, this output amplitude may not be determined by this complete I0 current switching to one of these transistors. And it may get clipped because there is a finite supply voltage. And this voltage limited regime, we will find that the MOSFETs get into more nonlinear region as compared to the current limited regime. Voltage limited regime will give you higher amplitude for a given tank with a given loss. We will see that it will give you lower amplitude but lesser nonlinearity. Whereas voltage limited regime will give you higher amplitude for a given tank, but they also come with more nonlinearity. Okay, so generally you'll see that when we are biasing the MOSFETs, we bias it at the edge of this current limited and voltage limited regime so as to get the maximum amplitude without increasing the nonlinearity. Generally, MOSFETs in cross-coupled LC oscillator are biased at the border of current limited and voltage limited regime.